Uh, Hello, my name is Hunter Downs. This is my CMAP2 video. I'm doing it over Lab7, and like the way I did it was I changed it a bit here just for the video. Um, Basically, the way that they've all worked so far, you get the IF stream from Argument Manager, all that fun stuff for output, input and output, and I use the file input to first get the size, source, and destination. If the source is the same as the destination, that means there automatically is a valid path between the source vertex and the destination vertex. So you just return true, output true and then return. Uh, if they aren't the same, you have to create, or at least what I did in Lab7 was create an adjacency matrix. Uh, Initialized it, all that fun stuff. Then I started taking the edges as input, and since it was undirected, I made the edges at edge 1 and edge 2 and edge 2 edge 1 both equal to 1. And then I used breadth first search to find if there was a valid path between them. But since I only used an adjacency matrix and BFS, I wanted to also talk about DFS with an adjacency matrix and also about BFS and DFS with an adjacency list. So like you see here, I already went over input, initializing the matrix, BFS, and BFS, as we should talk about in class and all that. BFS usually works with a queue, so you create a queue, an array of visited vertices. Set all those to false. Then you make the visited source equals to true, and you push the source onto the queue. And then while the queue is not empty, which means not done traversing with BFS or searching with BFS, you make the current integer using equal to the front of the queue, and then you pop it. You output the, or well, you wouldn't output it in the actual lab, but for this you output it. And then for every value that is adjacent to it, if it's not visited yet, you set it to visited, and you push it into the queue. And DFS works the same except with the stack. And for adjacency matrices, you use this matrix at the current integer or current row and the ith column for the words. The current integer in the ith column. And like you see here, if I run this, this is input 1, which means it's looking for a valid path between 5 and 2, and as you can see here, there is no valid path between 5 and 2. It's not showed up in BFS or DFS, and similarly with adjacency lists, which is similar except it's just a linked list. So works very similarly, except for BFS and DFS use while loops instead of a queue to iterate through like a linked list, because it is just a linked list. And you obviously initialize it a little bit differently. You set everything to node, and it's not a 2D array; it's a 1D array. But if I run this here, it will be a error 140, 140, 140. Okay. Oh, it's because I copied these lines right here from the other code. Sorry, I was doing this kind of a rush. As you can see here, it is the same for BFS and DFS. Or wait, it's the same values, not necessarily the same order, I guess. Because the iteration is a bit different. Yeah. But you see, we also see here, there's no path between 5 and 2 in these nodes, or at these edges, because you can see right here, 2 is only adjacent to 7, and 7 is only adjacent to 2. They're in this little, little group hug, which is why input 1, the answer is false. Let me see here. Input 3, it's looking for that 0 and 5. And then if I run this, we'll see 5 and 0. They're just to each other. So by default, there's a valid path because they're right next to each other. But say if this was 5, 1, since 1 is still connected to 0, you would still be able to get that valid path. And then same for the adjacent list. You get 5, 0. Oh, this. I feel like I went wrong somewhere. Oh, I don't think I. Yeah, you can see there is a valid path between 5 and 0. And that's basically my Lab7 plus showing the ways that I couldn't do it because we only needed one method of solving it for the matrices and the lists. Thank you for your time. Have a nice day. And yeah, that's it. Thank you.